Hi, this video is about the newly introduced UTXO index in the Neptune Core client. The UTXO index is a heavyweight index intended for heavyweight clients, for power users. It allows two new features. It allows for quick rescanning of historical blocks for all balance affecting UTXOs, and it allows the nodes that maintain a UTXO index to serve an extra RPC endpoint that's usable for lightweight wallets. The UTXO index lives as a field in the archival state, and the archival state is the part of the state that deals with all historical blocks. And we can see one of the fields here in the archival state is the UTXO index, and this this UTXO index state is then only maintained when that's specified at startup. So what does the archival state do with the UTXO index? Well, it initializes a database for it, and still initialization, and then it can update the UTXO index. So the way that this happens is that it looks at the latest block that was applied to the UTXO index. We call that current sync, and then we find the path from the current sync to the block we are applying now. It's a new block hash here, and that's all the missing blocks that will be applied to the UTXO index. So this function updates the UTXO index and it applies all missing blocks in history in case some blocks were processed previously but were not applied to the UTXO index, in case the client was started without the UTXO index previously. So this will always catch up. Once a new block arrives, this will ensure that the UTXO index is updated to the latest block. Right, so what does the UTXO index then actually look like? We have that it's best thought of as a database, or it is a database, and that database has some mappings or some tables if you want. And going through those mappings one by one, we have announcements by block. So that means you can specify a block digest, and then this mapping will return a list of, not a list of announcements, but a list of announcement flags. And that those announcement flags are just the two first elements in each announcement. Then it maintains a mapping again from block hash to the hash of all inputs in the block. So this can be used for quick rescanning for inputs that spend UTXOs under your wallet's control. And then we have the last mapping here, which is the inversion of the first mapping that I talked about. It allows you to specify an announcement flag, again just the two first element of an announcement, and then it will return this mapping will knows the list of block hashes in which this announcement flag exists, or rather in which announcements with these flags exist. Now the actual maintenance of the UTXO index happens in this function here, index block, and it converts all announcements that have a length of 2 and longer into announcement flags, removing duplicates, and then it inserts those into the announcements by block mapping here. And then it maintains the opposite mapping, which is the announcement flag to block hash mapping. And the way we do that is, we loop over all announcements or all announcement flags in the block, and check what block hashes already exist for those announcements, and then we update those entries. And lastly, it maintains the hash of the transaction inputs, such that wallets can quickly rescan for this. Now, as I mentioned earlier in the video, there are two purposes of this UTXO index. One is for the that the node can rescan all historical blocks for balance affecting UTXOs. And what does that function actually look like? Well, that lives in global state, and it's called rescanned. Well, there are 4 rescan functions. I think the most important could be this rescan announced incoming. It says rescan the specified range of blocks for incoming UTXOs that were announced on chain for the specified list of spending keys. Only works for nodes that maintain a UTXO index. Right, so you specify which keys you wanna scan for incoming announced UTXOs for, and the block range, and then for each key, each spending key, we can of course derive an address, and each address has an associated announcement flag, and this means that each address will only discover incoming announced UTXOs if the 2 first elements of the announcement match that address. So that's what we're calculating here. If you remember, in the UTXO index we maintained, so we don't have to put the entire announcement into the mappings. We only maintain these announcement flags values, and the corresponding announcement flags are calculated for each address of interest here. And then we simply loop over all blocks and rescan each block for announced incoming transaction. And of course, for that we need the UTXO index. So we say, well, what are the announcement flags for this specific for this specific block that we're looking at now? What are the announcement flags for this specific block we're looking at now? And do any of those match? And do any of those announcement match our keys or our addresses? If that's not the case, we return, and if that is the case, then we have to load the entire block from disk, which the archival state will allow us to do, and then we basically go through this the entire block and check it for incoming UTXOs. Because of how the wallet database is set up, that is quite fast. Now, the second rescan function that this UTXO index unlocks is what I've called rescan outgoing. Maybe it should be recalled rescan for spent UTXOs instead. But nevertheless, it again looks at the UTXO index and asks what are the hash values of the inputs, transaction inputs present in this block, and then it compares those hash values to anything that we are maintaining in our wallet. So a so-called monitored UTXO is a UTXO that the wallet owns. So it has the spending keys for that UTXO, and those monitored UTXOs can be looked up by the transaction input, or the hash of the transaction input. So that's what's going on here. So this lookup again is very, very fast. think microseconds. And yeah, we because it's so fast, we can basically just loop over all hashes of inputs in the block and check which one match monitored UTXOs in our wallet. And this function can actually runs without ever loading the entire block into from disk, because it can just look up from databases instead. So it's very fast. And for all matches, well, here we go into the database and we mark a UTXO as spent if there is a match in the specified block. And of course, it's worth mentioning that the local state is trusted. So we are not loading the blocks from disk, verifying it, checking that the block follows the consensus rule, because that was already done before the block was inserted into state. So we don't need to do that again. Right. The third rescan function that was recently added, that for rescanning historical blocks for balance affecting UTXO, is rescan expected incoming. So this is what you want to use if you do not want to associate UTXO for you with announcements that go on chain. If you want to use off-band communication for UTXOs or for UTXO information and UTXO recovery, this is relevant for you. And this rescan method actually works without the UTXO index. So it's kind of a bit separate, but since I was writing, different kinds of rescanning functions, I just wrote all of them, and then I realized that some of them could be written without the new UTXO index, because the other parts of the archival state maintain the necessary information. Again, says here never loads the entire block from disk, so performance is good. All lookups here are, I believe all lookups here happen in constant time. So again, performance here is really good. What can we see from this function here? We look at finding all the addition records for all for the canonical block with a specified block height, and then we say, do any of those addition record match any of our expected UTXOs? UTXO where we have the information, the required spending information, but we haven't observed it in on the blockchain yet. And again, this scan here works in because the wallet database can look up these expected UTXO by the addition record. This again, each lookup here is microseconds. Now, if there are no matches in this specified block, we continue, and otherwise we know that we have a match for an incoming, and yes, we loop over those and add those to the wallet. Now here, when we are rescanning for expected incoming transaction, it's worth noting that when we are actually inserting this into the wallet, registering with the wallet, this function here, insert monitored UTXO, it ensures that the same UTXO is never inserted twice. So yeah, that's guaranteed by the wallet database, that there can be no duplicates. And the fourth rescanning function that was recently added is rescanning for guesser rewards. This is only relevant if you've been doing the guessing part of the mining process and you have lost your wallet database, you still have your seed, and you've also lost the file called incoming randomness. In that case, you can run this rescan guesser rewards. It will rescan the specified range of blocks for guesser rewards for your wallet. And if I remember correctly, this one also works without loading the entire block from disk. So again, performance is no, it does not. I'm wrong. It does load the entire block from disk, because that's the only way that we can see how big the guesser rewards are. We need to know that in order to construct the UTXO for that we are adding to the wallet. So, but it only loads the block if there is a match. If this block was guessed by us and those rewards are not already present in the wallet. So unless you found all historical blocks, the performance here again should be very, very good. Now those were the four newly introduced rescan functions, and the second part that the UTXO Index unlocks is a new endpoint that can be used to serve lightweight wallets. So this new endpoint is called block hashes by flags, and it takes as input, it takes, let's see, it takes a list of announcement flags. So this means that the wallet, the lightweight wallet, that could be running on a cell phone, it looks at all the addresses that its wallet controls, then it calculates the it calculates the associated announcements flags for all the addresses under its control. Hopefully it adds some decoys here so it doesn't leak privacy to the server, and then it sends this list to the server, the list of announcement flags to the server. The server then looks up through the UTXO index which block hashes have announcements matching these announcement flags and returns that. Now it's worth noting here that this mapping here, block hashes by announcement flag, the mapping that maps announcement flags to a block hash, that it is because of a denial of service attack, it is actually capped in length. So if your wallet has received more than currently the limit is set to 10,000. So if your wallet has received more than announced incoming UTXOs in more than 10,000 different blocks, this result here will only return the first 10,000 block hashes. But if you're receiving that many UTXOs anyway, then you should probably be running your own archival state. And you can also just see that this limit here is capped by 10,000, so you can see that there's something that has been pruned. Right. For 99.99% of all wallet software, lightweight wallet software, they'll of course not receive announced incoming UTXOs in more than 10,000 blocks, 10,000 different blocks. So this will work perfectly for them. And I think this will be very, very valuable for lightweight clients, because it allows the lightweight wallets or the lightweight clients to quickly figure out which blocks to rescan for incoming announced UTXOs. Right, I believe this endpoint here, will be very valuable for these new up and coming lightweight clients that can run on a cell phone.